Hello class, today we're going to go ahead and discuss the slope of a line. The slope of a line is really the point of inclination, how a line inclines. So if you were to see something like this, where you have a graph and your line inclines this way, this is said to have a positive slope. All right, and if you have another graph, let's say you have something like this, where your line goes this way and inclines that way, then that is said to have a negative slope. So those are generic things, generic graphs that we'll have. So if it inclines this way, this particular way right there, so to have a positive slope. If it inclines that way, it has to be a negative slope. For our purposes, we're going to need a little bit on that, but it's more observational than anything else. For our main definition for a slope is going to be rise over run. In other words, the changes in y over the changes in x. And you're going to denote the slope with this letter right here, this letter M right there. So whenever you see that M, that signifies that you're searching for the slope. Now we have to put it in context, a little bit more concrete than just using this definition right here. So we have this slope formula right here. So it'll be y to the second minus y to the first, x to the second minus x to the first. Now these are subscripts. These are not exponents. What they mean is that you're getting the second y minus the first y subtracted over the second x minus the first x. So in other words, you're going to label your ordered pairs x1, y1, x2, y2, so you know where you're getting them from. So let me give you a quick example of those. So for example, the first one here that we have is 5, 3, and 9, 6. So we're going to label these as x1, y1, x2, y2. So we go ahead and substitute it into that formula. And once again, follow the order. It's y to the second first. So y to the second here is 6 minus y to the first. Y to the first here is 3 over x to the second. X to the second is 9 minus x to the first. X to the first is 5. So what you're going to do is figure out the differences between your y's and the differences between your x's. So if we subtract 6 minus 3, that means it's 3. 9 minus 5, that's 4. So the slope of this will be 3 over 4, and it's said to be a positive slope. In other words, if you were to plot these 2 points and connect them, they should incline this way, just like you had in our previous one right here. All right? So the inclination is said to have a positive slope right there. Now just check it out real quick. From 3 to 6, it rose 3. That's why it's positive 3. From 5 to 9, it went 4 places to the right. That's why it's positive 4. So once again, the changes of y over x, that's really what you're solving for here. And once again, we're using this slope formula right there. It's a very important one here. Let's try another one. Okay, so we're going to go ahead and label this x1, y1, x2, y2. So, first of all, y to the second is negative 9 minus y to the first, which is 8. So remember the slope formula. it's y to the second minus y to the first. So in this case, we have negative 9 minus 8, and x to the second. In this case, it's going to be negative 3 minus x to the first, which is negative 5. That negative is separate from this minus sign right there. So you're going to see some sign changes there. So we're going to go ahead and subtract these two. Negative 9 minus 8, that'll give you negative 17. Here we're going to have the double negatives. So it's negative 3 plus 5. So this will be negative 17 over, and you subtract these two, keep the sign of the larger one, positive 2. So your slope here is negative 17 over 2. So it's said to have a negative slope. So once again, if you think about it, you went from positive 8 to negative 9. So that means that you lost. In other words, it went down 17 places. And you went from negative 5 to negative 3, which means that you gained 2 places because you move from negative 5 to negative 3. And that's essentially what you did. But instead of doing it that way, that's why we use our slope formula. Now, you could ask yourself, could we have slopes of 0? Yes, you can. And our next example right there is a perfect example of that. So, once again, label this. This is x to the first, y to the first, x to the second, y to the second. So here, y to the second is negative 5 minus y to the first, which is also negative 5. And then we have x to the second, which is negative 3, minus x to the first, which is negative 8. So once again, we're going to do some sign changes here. We have the double negative here, so it's negative 5 plus 5. And we also have the double negatives right there. So this will be negative 3 plus 8. So once again, we're going to have to subtract and keep the sign of the larger one. But you're going to notice that on top, both of them are the same. So negative 5 plus 5 will end up giving you 0. So you're going to go ahead and subtract those two. At the bottom, you have negative 3 plus 8. So you subtract and you end up with positive 5. So 0 over 5 essentially becomes 0. Now, could you have the 0 at the bottom? Yes. If both of these are the same and they cancel each other out, then yes, you could have a 0 at the bottom. In that case, your slope will be undefined. All right, so this concludes part 1 of section 7.3.